So in Chapter 1, Section 4, we looked at quadratic equations, and now we want to extend our use of quadratics to include quadratic functions and word problems. So although the instructions say we want to draw the graph by plotting points, we're actually not going to be doing that so much as using our calculator. From the calculator, we can get our points to be plotted. So begin with the y equals, enter the function. You can use this key for x squared plus 4x minus 4. And we'll start our graph with zoom number 6 to reset the window to a standard window. Now, if we need to transcribe specific points, such as onto our graph, we can use the table key, which is in the upper right, second table, and we can get some points off of that. Now, I'll just point out that for this quadratic equation function, you notice here -2, -8 is surrounded above and below by identical numbers, which means that -2, -8 is the vertex. So, what we just found is that here is the point -2, -8, the vertex. I also recall there being a point at -1, -7. And the only other point that I remember was 0, -4. So from these three, we can draw the rest of the graph. There's a line, imaginary of course, running vertically through the vertex. This line is called the line of symmetry. The dot here at -1, -7 has a matching dot here at -3, -7. Likewise, the dot at 0, -4 has a matching dot at -4, -4. And so we could just construct the graph that goes through there and on out forever. And no, that's not very cool looking. However, the question down here is what's the domain and range? The domain is pretty easy. All quadratics have the same domain, and that is all real numbers. We oftentimes, however, need to say that a little fancier. And here's how we say all real numbers. -infinity, comma, infinity. All real numbers. The range, however, for this quadratic is this. Notice the lowest dot on this graph is at -8. So the range starts at -8 and goes forever. That would be infinity. Since there is a dot at -8, it would have a bracket. So as with the previous function, we're going to use our calculator. So we start with the y equals. Now for the negative sign, be sure that you use the one at the very bottom that has parentheses around it. The one over on the right that's up above the plus key, below the times key, is the subtraction key, not the negative key. So here's negative, and then here's the 2x squared. Now, we've already done zoom 6, so we'll just hit the graph button and see, do we see an appropriate graph? And sure enough, there it is. You could probably tell by looking, but let me show you again. Second table, I get a list of values. Notice here at 0, 0. Up above the 0, there's a negative 2. Down below the 0, there's a negative 2. Since those numbers are identical, this is the vertex. And so we can construct a hand-drawn graph from some of these points with the vertex at 0, 0. So from what I just did on my calculator, I know that there's a dot here at 0, 0, the vertex. There's also a dot at 1, negative 2, and at 2, negative 8. This is the vertex, so there is again an imaginary line going through the vertex, straight up and down, called the line of symmetry. You'll be asked about that in some of the questions. Since there's a dot here at 1, negative 2, there's going to be one here at negative 1, negative 2. Symmetric with it. And likewise, there will be a dot at negative 2, negative 8. So drawing a parabola through those dots, or at least close to those dots, we get a rudimentary graph. The important thing, though, is the domain, which I just got through telling you was always the same. And the range, which we say negative infinity, comma, 0. So y equals, again, the negative is on the very bottom in parentheses. And here's the 2, parentheses, x plus 3. And then the square, and plus 5. I'll have a look at the graph on a standard window still and be sure I see what I need to see. Again, the details come from using second and table. And again, I see here negative 3, 5. Above the 5, there's a 3. Below the 5, there's a 3. That tells me negative 3, comma 5 is the vertex. And I need some of the other points. So from what I did on my calculator, I know that there's a point at negative 3, 5, and that was the vertex. There was also a point at negative 2, 3, and there was also a point at negative 1, negative 3. Now, those are the only points that I'm going to bother with. The line of symmetry goes vertically through the vertex. There is a matching dot for this one here. There's a matching dot for this one here. So the graph would go down on the left, down on the right. The domain, hopefully you've caught on to that by now, and the range goes from negative infinity, meaning way down there, we won't say who's down there, comma, and then the highest point is here at 5. And again, since there's a dot there, we will use the bracket. Starting with the y equals. Here's negative 3x squared plus 12x minus 8. If everything works well, we'll see the graph when we hit the graph key. And sure enough, there it is. We'll use the table to find points. I'm looking down through my table, and I notice that here is 2, 4, where the 4 has the same number above it as below it. That tells me 2, 4 is the vertex. So when you enter the answers, like in the homework, the vertex you would enter as the point, meaning parentheses, 2, 4. Now the axis you enter as an equation, x equals 2, because it's the vertical line through x equals 2. I have 4 more examples to show you that are all part of the same problem. Just various things that are being asked about this particular motion problem. So to begin with, we're given this formula, if you will, where v with a subscript of 0, which is usually pronounced v naught, and s with a subscript of 0 represent the initial conditions. So we're told that initially the height was 75. Now that is the s. Don't ask me why height is s, but it is. And so all we do is we put a 75 there. And the initial velocity is 112, so we put a 112 there. And that's our answer. So now that we have the equation, we can use our calculator, sort of. Notice that this one has the variable t. Now that's a problem. Our calculator doesn't understand the variable t. But that's okay. We can use x's. And this would be the y. So x's is going to be our time, and y is going to be our height. Starting with y equals, we're going to do the negative 16, only x squared So now remember, we were on a standard graphing window. If I hit the graph button, I'm going to see some sort of graph, or hopefully see some sort of graph. But this is not the graph I expected. I expected a parabola. So I sort of think that the parabola goes up to some point and then back down again. So I'm thinking the vertex is somewhere in between these two lines. If I go to the window setting, I need to make the value of y larger. Down here where it says y max, I need something bigger than a 10. Now here it becomes kind of guesswork, and your calculator can draw the graph so quickly, if it's not what you wanted, you can change it and try again. For example, I know that when t is a 0, we're going to get a 75. So how about if I just start off trying like an 80? I hit the graph button, it draws the graph. Now the reason the y-axis looks so thick is because it's putting all the marks right on top of each other. But again, as you can see, that's not near enough. Don't go too far overboard, but jump up to a higher number. If we go to the window setting, go to the 80 that we just typed in and make it something larger, like maybe a 300. Hopefully we will see a nice parabola. And sure enough, there appears to be a vertex right in there. So we're going to have a look at the table. That's helped us out so far. And what are we looking for in the table? We're looking for a point where the numbers above and below are identical. Let me just point out that down here we have 3 and 267. Just below that is a 4 and 267. Because those two numbers are identical, the 267s, we know the vertex has to be in the middle, meaning halfway between the 3 and the 4, which, if I'm not mistaken, comes out to be a 3.5. Now we're also going to need to know what is the y value for 3.5. Let me show you how to get that. If I go back to the graph, I can use the button right next to it called Trace, and I can type in the 3.5. And lo and behold, the readout at the bottom says y is 271. So there's the vertex, 3.5, 271. So the question, how many seconds is the x, the t, and that's the 3.5. The maximum height, which is the y on our calculator, or the s, was the 271. So in this example, notice we're looking for the time, t, which on our calculator is going to be x, when the height of the ball is bigger than 200. Now the height of the ball is the s in this equation, which is the y on our calculator. So we need the t's where y is bigger than 200. So remember, on our calculator, the height means the y value. So we want to know where is y bigger than 200. If we go to the y equals and put us a line at 200, here's what we will see. So the blue line represents our projectile, and the red line is 200. So the question is, where's the blue line above the red line? And so we need to find the point on the left and the point on the right where the red and the blue cross. Now this is our first installment of using this particular technique, and it will not by any means be the last. We can go second, calc, number 5 to find out where they intersect. Now here's how it works. We're going to move the x along the curve until it's close to where they cross, and press enter 3 times. And there's our answer. So we got x equals 1.39, or t. So 1.39 seconds is when it gets to the 200-foot mark, and then it's continuing to go up. We're going to go second, calc, number 5. Continue moving our cursor until it's close to where they cross on the other side of the hump, and press enter 3 times. And there is the other point where it falls down below 200 feet. So between 1.39 seconds and 5.61 seconds, it's above 200 feet. So in this final example, we're trying to find how long until the ball hits the ground. Well, hitting the ground means the height is 0, which means we need our y value to be a 0. I'll show you how to do that with the calculator. So now the last question is asking about when the ball hits the ground. Well, if it's on the ground, the height is 0. And on our calculator, y is the height. So we're going to go to our y equals. For y2, we're going to use a 0. Just like with the previous example, when we look at the graph, we get the path of the projectile and the ground. And we need that value on the right where they're crossing, just like with the previous problem. Second calc, number 5, move close to where they cross. Now there's no magic in how close you get, just close. And press enter 3 times. 7.62.